Hello friends, welcome to engineering tutorial. In today's video we are going to take our discussion forward on the various network topologies. Previously we have discussed about mesh and star topology. So in today's video we are going to discuss about another network topology or network design, which is the bus topology. So the bus topology is a multi-point network connection where all the nodes are connected in a multi-point way. Okay, so what is multi-point connection? So in a multi-point connection, more than two devices or nodes are connected in between a particular communication pathway or a communication link, which means the network capacity, okay, the link capacity, the channel capacity is shared between the multiple devices. In point-to-point connection, only two devices are connected between a link, and the entire capacity of the link is reserved for communication between only those two devices. But in multi-point connection, the capacity of the link is shared. It can either be shared simultaneously, which is called as spatial connection, or temporarily. Okay, so in bus topology, multi-point connection is used. Now in the previous two topologies such as mesh and star, point-to-point connection was used. It means in between two devices only one dedicated link was present. So in bus topology, it uses multi-point connection. Here one long cable or one long wire acts as the main communication line, the main communication pathway, which is also called as the backbone, and all the devices, all the other nodes are connected to that main cable. Okay, so the bus topology looks something like this. Okay, this straight line is the main cable. Okay, here is one cable end, here is another cable end. Okay, this straight line, horizontal line, is the main cable, which is the single communication line, which is called as the backbone of the network. And all the devices, here there are 4 devices, are connected to this main cable. Okay, so this is how a bus topology looks like, and here it is multi-point connection. Here the capacity of this single main line, single cable, is shared in between these 4 devices. It can either be shared simultaneously or temporarily. It means the devices can either take turns, wait for their turn for communication, or they can do it simultaneously. So the devices are connected to this main cable through taps and drop lines. Okay, so what are taps and drop lines? Okay, a drop line is a connection between the device and the main cable. Okay, these vertical lines between the main cable and the device is called as the drop line. It forms a connection between the main cable and the device. The device can be anything. It can be a computer, it can be a smartphone, or it can be any hardware peripheral device such as a printer or a scanner, anything. Okay, so this drop line forms a connection between the main cable and the device, specific device, and this drop line is connected to the main cable with the help of a tap connection. Okay, a tap is a connector of sort. Okay, it is a connector which connects the device with the main line or the main cable. Okay, a tap is a connector which connects the device with the main cable. It can either be done through splicing technique, okay, it can either be with the help of splicing is the technique which is used in various electrical purposes, where a wire is cut with the help of a wire cutter in order to expose the metallic connection. Usually the wires are coated with an insulation medium over them. So in order to expose the metallic wire, which is normally made of copper, the splicing technique is used. Okay, so first the wire is spliced and then the metallic connection is connected to the tap so that a connection is formed. Okay, what I am talking about is this. This is a wire. A wire looks something like this. This is the outer covering, okay, outer insulation covering, which is called as the jacket. It can be made of any insulating medium. Then there is an inner covering, and this is the metallic contact. Splicing exposes this metallic contact, okay, this conducting medium, which is generally made of copper wires. So this metallic contact is connected, okay, this brown metallic contact is connected to the tap, and then it forms a conducting connection to the main cable. Okay, so the tap achieves this. Okay, so this is how a connection is made. Okay, so this is how a bus topology network looks like. Now, how does this network work? Okay, so this is how the bus topology looks like, and it uses multi-point connection. It means that the entire capacity of this main cable is shared by the various devices connected to it. Okay, now this sharing of the channel capacity can be of two types. Okay, it can be spatial. It means that the communication can take place between any two devices simultaneously. Okay, simultaneous transmission and reception of data. Or it can be through temporal connection, means time shared connection. It means that at any given point of time there can be communication taking place only between two pairs of devices, a pair of devices. Okay, only two devices can be involved in communication. Okay, if any particular pair of devices is involved, then the other device has to wait until that transmission or data communication is over. Only then that device can communicate data or transmit or receive data. Okay, so this is how the bus topology works through multi-point connection. Okay, now let us discuss the advantages and disadvantages of bus topology. So as you can see, in bus topology only a main cable is involved and the devices are connected through taps and drop lines. So the amount of cabling or wiring required is much less when we compare it to mesh and star topology. So less wiring and cabling, which makes the connection very simple, and because of that the installation process is relatively easy and the cost is also less. Okay, these are the advantages of bus topology. Now the disadvantages. Now in bus topology, the communication between any two devices is heavily dependent on this main cable, okay, this backbone. So if any defect occurs in this main cable, it will shut down the communication between all the devices. Okay, any defect in this main cable will shut down all the communication between all the devices. So that is one of the major disadvantages of bus topology, heavy dependence on one particular feature of the system. Okay, here it is heavily dependent on this main cable. Also, fault location and isolation is very difficult. It is very difficult to locate the defect in the bus topology. Okay, whether the defect is in the tap or in the main cable or the drop line. Okay, so this is very difficult to identify the defect. Okay, so this is another disadvantage of bus topology. And another disadvantage, technical disadvantage, is that suppose we have this bus topology consisting of 4 devices. The network is set up. Suppose you want to add extra devices, then additional splicing, puncture, and additional taps and drop lines, additional connections will be required. Okay, so the cost of that is very high. It is not that flexible, that easy to add more devices to a bus topology network. Okay, so these are some of the disadvantages of bus topology, and an example of bus topology is the Ethernet LAN. Okay, the Ethernet local area network. This method of network connection uses bus topology. We'll discuss about that in detail, but here just you know that the Ethernet LAN is a example of bus topology. We'll discuss about these things in detail. It would be unnecessary to explain Ethernet LAN in this video, because I would explain it in a separate video, so you don't worry about that. Okay, so here we have discussed the basic concepts related to bus topology, the network design, the concept of splicing and taps and drop lines, and we discussed the advantages and disadvantages and also the example. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.